Hello everyone. Today we are going to start the next program, that is the fourth experiment on the MATLAB, which is to add, subtract and multiplication of any two discrete time, finite length discrete time signals. So program to find the addition, subtraction and multiplication of any two discrete time signals. So now while adding any two discrete, adding or subtracting one from another, and multiplication of any two discrete time signal, there are a few things to be considered. The first thing, whether it is addition or subtraction or multiplication, it is always sample by sample in its corresponding position only. So that means signal, suppose x1, the signal value at -1 will be added or being multiplied or being subtracted from or to the signal value of say x2 at -1 only. So therefore it is subtraction, addition, subtraction, multiplication is always by the corresponding sample values only. So we have to take care of this. Second thing, while doing it in MATLAB or any other computing, the MATLAB considered the signal values as a row vectors. So therefore, while adding or subtracting or multiplication of two row vectors, according to the matrix algebra, it has to be of the same size. Suppose x1 is having 6 samples, x2 will also must have the 6 number of samples. Then only both can be added or subtracted or multiplied. That is the second thing. The third thing, since we have to maintain these two, that is first one, sample by sample, that is in its corresponding values, and second thing, in MATLAB the number of elements, that is in the row vector for both the signals, must be same. So therefore, while maintaining both, somewhere we might add some zeros to make the signal equal and to maintain the same corresponding time index for both the signals. But this thing should be automatic for any discrete time signal. Therefore, for example, I am just showing you with an example. For example, this is my x1 of n, where this -8 occurs at 0. So therefore the 6 at -1, 4 at -2, 1 at -3. This plus 4 is at +1, is at +2, this 2 is at +3, -3 is at +3, and 4 is at 4. So therefore this time here, so let me put it as n1, which is equal to -3, then -2, then -1, then 0, then 1, then 2, then 3, then 4. So this is my n1. Similarly, the second one, the signal x2, this is my suppose x2. So here suppose my n2, which is at this is at -2, this is at -2, -5 is at -2, then 3 is at -1, then -6 is at 0, this 2 is at 1, then this 7 is at 2, 8 is at 3, 3 is at 4, -3 is at 5, and this 5 is at 6. So this here, the first signal is having, suppose the number of sample n1 is 9. Similarly, the second signal also having the number of sample is equal to 9. Now while adding or subtracting or multiplying this x1 and x2 thing is, as I mentioned, the first thing is its corresponding value will get multiplied. So therefore this 6 will be added or multiplied or subtracted from this 8 only, because this is the corresponding time. Similarly, this minus 3 will be added or subtracted with this 6, that is at minus 1 value. Similarly, this 5 will be added with 4, then this 2 will be with the 4, then 7 will be with 8, and then this 8 will be with 2, then this minus 3 will be with 3, then minus 3 will be 4, then this 5. So there is no further samples available here in this x1, so what you have to do, you have to put a 0 over here. Okay. Similarly, this 4, this 1, there is no such signal, so therefore here also we have to put a 0 at the leftmost. Now how will you make this automatic? It has to be automatic for any kind of signals. Okay. So therefore what we can do is, here I can put one 0 here, and also here I can put one 0, so to make it equal. So see, so now what we did is, to make the signal length equal, here we need to put a 0 and here we need to put a 0. One is at the rightmost, one is at the leftmost. So similarly, the time scale here, as you can see, this time scale get modified, and here also this time scale get modified. Okay. So therefore total number of sample here becomes 10, and here also the total number of sample becomes 10. So how we can make it here, how we can make it automatic. So what we do is, originally in this, the first case, the n start, small n start, small n star was your -3, and small n stop or end was your 5. Similarly here, n2 start was your -2, and n2 I will make it n1. This is n2, sorry, n1n, n1n, and here n2 start, n2 is equal to 6. So what you need to do is, so as you can see in this first signal, there need not to put any zeros at the leftmost. So how can we decide? But here it needs to put a 0. So the first signal, the n1 start, which is at -3, then n2 start, which is at -2. That means the minimum of these two is -3. Okay. So the signal, new signal, I mean the final time, so let it be n, will be equal to minimum of your n1 start, minimum of n1 start and n2 start. And it will go up to the maximum of n2 end and n2 end. So as you can see here n minimum of n1 start n2 start is -2, that is -3 and -2, so minimum is -3, and it will go maximum is 6, 5 and 6, so maximum is 6. So finally the resultant signal will be from -3 to 6. Okay, so resultant signal will be from -3 to 6. Now since it is already started at -3, so here you need not to put a 0, but here it is originally started at -2, so you need to put a 0. So how can we make this generalized? This is for a particular case, this is minimum this is minimum n1, and this is greater than this, because minus 2 is greater than minus 2. So therefore, to make it generalized, so x1 is equal to, what we will do is we have to put zeros. In MATLAB it is the command is zeros within bracket. The one is to make it in a row, one row, comma, how many zeros? Here, as you can see in this example, there is no need to put any zeros, but to make it generalized, so it will be minus 3 minus 2. So what it will be, minus 3 minus 2 will be minus 1. So 0 is 1 comma minus 1. That means it will create a null matrix. So to make it generalized, what we will do is n1 start minus n2 start minus n2 start. Okay, so that many zeros will be at the leftmost. So in this particular case, there will be no zeros at this position. So because n1 start is minus 3, n2 start is minus 2, so minus 3 minus 2, that is plus 2, so it will be minus 1, and zeros 1 comma minus 1 is a null matrix. As you can see, say for example, here you can see zeros 1 comma say minus 1, it will be a null matrix. You see, empty matrix. So then the signal, the original signal x1, then at the end, as you can see here, we need to put a 0. So again you put zeros, zeros within bracket 1 comma, so how many zeros? Here 1 zeros. How can you define the 1 zeros? Because the signal x2 is having 6 number of samples, n values, and n point is 6, and signal x1 is having the n point 5, so 6 minus 5, 1. So therefore it will be n to end minus n1 end. So you better you put it in a bracket. Okay, so that way it will. Now see, in the n2 end is 6, n1 end is 5, so 1 zeros will be put. So this is the 1 0. Similarly, you just modify this for x2. Similarly for x2, as you can see in the x2, at the beginning you need to put a 0. So here it will be just opposite. So it will be n2 start minus n1 start. So what is n2 start? Minus 2. N1 start minus 3. So minus 2 minus plus 3. So it will be 1. So there will be 1 zeros at the beginning. And then the original values of the x2. And then at the end, as you can see here, no need to put any zeros because it has already 6 at the end, that is the maximum one. So here it will be n1 end, that is 5, minus n2 end, that is 6. So if you, it is minus 1, so 0 is 1 comma minus 1, which is a null matrix. So there won't be any zeros. So finally your x1 becomes this, x2 becomes this. Now if you add, suppose x1 plus x2, it will be 1 plus 0, 4 plus 5, 6 plus 3, minus 8 plus minus 6, 4 plus 2, 8 plus 7, 2 plus 8, minus 3 plus 3, 4 plus minus 3, 0 plus 5. Similarly, if you multiply 1 into 0, 4 into 5 like that, or if you subtract, suppose x1 minus x2, so 1 minus 0, 4 minus 5, 6 minus 3, minus 8 minus 6, like that. Okay, and the time scale, as I have said, it corresponding, so minus corresponding values, so minus 8, that is at 0, minus 6 at 0. So therefore the time scale, the new time scale will be the minimum of these two, that is n1 start and n2 start, which is minus 3 and minus 2. So the minimum of this is minus 3, and up till maximum of n1n to n2n, which is 5 and 6, so maximum is 6, so minus 3 to minus 6. So that's all about this. So you see this here, the program again. Any MATLAB program, as already I mentioned in the previous lecture, that CLC, clear or close, all these three are the consolidation tasks. CLC is to clear the command window, clear all is to clear all the variable in the workspace, close all is to close all the previously open figure window. Now the signal, so we have to take two signals. Again I am repeating that while considering or while taking any signal into MATLAB, the first thing is to consider the starting time index of the signal. So which is, I am considering here m1, but here in this example I considered it to be n1 start, n1n, n2 start, n1, n2n. Instead of n1 start, I am considering here m1. So m1, again this input to prompt the user to give the entry. So enter the starting point of the first discrete time signal, then the signal values x1, input, enter the discrete time signal values, then k1 is the length of the signal x1, because we need to calculate the ending time of the signal, so length of the x1. So these things already we have discussed. So m2 is my start ending time index of the signal x1, which is nothing but the number of samples plus the starting time index minus 1. So finally the signal is time scale for the signal is m1 to m2, that is time scale of the signal x1. So subplot again. Now in this case what we do is total number of 6 plots we required. First is for the signal x1, second is for the signal x2, third is for the addition of x1 x2, fourth is for multiplication of x1 x2, and fifth is for subtraction of x1 x2. So we cannot make it 5 because it is always the subplot can make divide the window in a number of rows and number of columns, so it can't be 5 or it can be 7, so it will be 4, 6, 9, like that only. So therefore we need to have 6 at least. So this 3, subplot 3, that is 3 rows 2 columns. You can make 2 3 also, 2 rows 3 columns. So 3 rows 2 columns, the figure 1. So in this figure 1 stem is for discrete time signal, then x1, for discrete time signal the plotting function is the stem. Again this x-axis value is here m, y-axis value is the signal amplitude x1, and r stands for the color red, and here is the title. Okay, similarly the same procedure we are just following for the next signal. So next signal I am considering time n1, n2. So n1 is the starting time of the second signal, y1 is the values of the signal and sample values of the signal, k2 is the length of the signal y1, n2 is the ending time index of the signal y1, and the time scale for the signal y1 is n1 to n2. Again subplot, plot, so up till this both the signal representation is done. Then second point, as I mentioned, here to maintain the timing as well as the length of the signal. So here, which I am considering as a mapping process. So the same procedure as I explained here has been explained coded here. So zeros 1 comma m1 minus n1. Here instead of this I considered the n1 start for m1 and 2 start for n1. So here 1 comma m1 minus n1, x1 the original values, zeros, like that, the same procedure that as I have explained. So my now new signal is, instead of x1 it is x, instead of y1 it is y, and time scale will be minimum of m1 n2 m1 n1 to maximum of m2 n1, so s1 to s2. Now once the addition is simply now the time becomes both the signal have the corresponding values of each time index, and the length of the matrix is vector, row vector is also same. So simply you can add it up. So in MATLAB it's straight to x plus y, similarly x minus y, and similarly multiplication, but since it is the element by element multiplication, you have to put this dot star. Only star is normal matrix multiplication, so we have to provide here dot. Any dot operation is element by element, and in the correspondingly we have subplot. So that's all. So with this example, let us see here. Suppose if I do the addition, suppose my z1 is equal to x1 say plus x2, so what it will be? It will be your 1 plus 0 1, 4 plus 5 9, 1 9, 1 9, then 6 plus 3 9, minus 8 minus 6 minus 14, and so on and so forth. That way it will be adding up. Similarly subtraction, multiplication. Let's see here. So let us run it. So as you can see here, enter the starting point of the first signal. So let us take the same example here. What is my starting point? Minus 3. So let us put minus 3 here. Then enter the signal values. Let us put these values only. Okay. So this is my first signal. So as you can see, the first signal get plotted here. This is the first signal get plotted. Now under the starting point of the second signal, so my second signal here is started at minus 2. So I'm giving here minus 2, and the signal values I am putting here as like this one. Okay, this is the second signal. So that's all. You can see the result here. It is being plotted here. So this is the original time. First one, second one, addition of 2, subtraction of 2, multiplication of 2. You can see the result here. So as you can see, my first is m, second is n, and x and y, and result is Z1, Z2, Z3. Okay. So first signal M, it is from minus 3. So minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So M is, I can see, minus 3 to 5. So this is my x1. 1, 4, 6, minus 8, this one. Then N will be from minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. So N will be minus 2 to 6. Okay. And the signal is your x2. It's not x2, but that's the signal. Oh, sorry, y1. The signal is not the x2, it is y1. So y1, this is the signal values. 5, 3, minus 6, 2, 7, 8, 3, minus 3, 5. Okay. Now, new time scale, which I am considering S. S is now minus 3 to minus 6, plus 6. Now in this case, X, you see the 0, Y, 0 is this side. Now Z1 addition, so it is 1 plus 0, 1, 4 plus 5, oh, it is minus Z1. What is Z1? Let me see what is Z1. Z1, where is the Z1? Oh, sorry, Z1 is subtraction. Yeah, Z is addition. So, okay. So, this Z1 is subtraction. So, 1 minus 0, 1, 4 minus 5 minus 1, 6 minus 3, 3, minus 8 minus 6 minus 2, 4 minus 2, 2, 8 minus 7, 1, 2 minus 8, 3 minus 6, minus 3, minus 3 minus 6, 4 minus 3, 7, 0 minus 5. Z is your addition. So 1 plus 0, 1, 4 plus 5, 9, 6 plus 3, 9, minus 8 plus minus 6 minus 4, like that. And Z2 is your multiplication. Okay, that's all. Thank you for listening. For any query regarding this program, please feel free to contact me. Okay, so at this point I would like to request you to do any kind of program. So till now what we did is, from the beginning what we did is generation of discrete time signals. For that we generated unit step, unit impulse, and then unit ramp. So this we have already generated. Number 2, what we did, number 2 we did the folding, shifting, folding, shifting, scaling means amplitude scaling. That is, and suppose a signal x of n, in this signal suppose there is a scalar 5. So 5 into 1 5, 5 into 4 20, 5 into 6 30, like that. This is the amplitude, just 5 star the signal. Amplitude scaling. The third what we did is time scaling, time scaling, and fourth what we did is signal arithmetics. Okay, so based on that you can do some assignment. So assignment number 1, from the following for discrete signal x of n. So you do like this, say y of n is equal to 5 into x of n plus 4 into x of n minus 2, say plus 3 into x of trisun. So here what you have to do is, in this example, in this assignment, what you have to do is, first you have to take number 1, you have to take the, so how will you do this? Number 1, signal x of n. So for this, what you have to do, take the starting time index of x of n, say n1. Okay. Number 2, take the sample values of x of n x. Then number 3, calculate the length of x, say L. Then number 4, calculate the ending time, the index of x of n as, say n2 as n2 is equal to L plus n1 minus 1. So then plot it using circuit. Okay, so that up till this the representation of the signal is done. Okay. Then number 2, what you need to do is number 2, perform since 5 is a constant, so you can put it directly. Perform 5 into x of n in new variable, say x1. Okay, then number 3, perform x of n minus 2, which is already we did the shifting operation, followed by 4 into x of n minus 2 in a new variable, say x2. Okay, then next perform x of 3n, this is the scaling already we did, followed by 3 into x of 3n in a new variable, say x3. Okay, so now your x1, x2, x3. So x1 is for this part, x2 is for this part, x3 is for this part. Okay, so what next? Next you have to maintain the starting time and the ending time of the combined signal as we did here by following this. So in this case there was only 2, now you have 3, x1, x2, x3. So what you can do is you can find out the minimum and maximum. So together I will call it as mapping of x1, x2 and x3. So how will you map? First you need to find out the starting time index. Find out the minimum of the starting time index of x1, x2 and x3. So as it being scaled up, so here while doing, say for the first one, this one 5 into x1, the time index does not change because it is amplitude operation. Since it is an amplitude operation, time duration does not change as it was there in the signal xn, so remains same. But the second one, x of n minus 2, because it is a shifting operation, so time index will modify. So you have to consider the new time index of this. But here once it is multiplied, this and this will have the same time index because this part is the amplitude operation. So whatever be the time information or time index was there in this will remain same in this. Similarly, this is also time operation, so the time information gets changed, but whatever be the time information you will obtain here will be remain same for this. So what you consider is you use some new variables for the starting time and the ending time for x1, x2 and x3, out of which you find the minimum of the starting time indices of x1, then the maximum of ending time indices of x1, x2 and x3. Here also it is x1, x2, x3, x1, x2 and x3. So this minimum to maximum will be your new time scale. So you will get new time scale. Then put zeros at the beginning and ending of all that is x1, x2 and x3. In generalized manner. So generalized manner, what I mean is by following this convention. So here it will be 0s 1 n1 star minus n2 star. So as you can see here, n1 was minus 3 minus 2. So what you need to do here, because it was 2 there, that is why it is directly the time index. But here whatever be the minimum of the starting time index of 3 minus this, like that. Similarly maximum minus time index of that segment. So suppose for x1 in this case, for this case how it will be, minimum of the starting time of the x1, x2, x3 minus the starting time of the x1, maximum of n1 x starting ending time of x1, x2, x3 whatever be the variable minus the ending time of x1, so and so forth. Okay, so after this you will be ready with the starting and ending time, maintaining and starting and ending time of all the three, as well as the length of the x1, x2, x3. So finally what you can do is you can add it up. So y is equal to x1 plus x2 plus x3 and plot it. Okay. Also plot the intermediate results, that is x1, x2 and x3. Hope you are following. Okay, so that's all. That is the assignment. So likewise you do another one. of I of n is equal to 2x of minus n, 4x of n plus 2, 3 into x of n divided by 3. So I am forwarding this page along with the video. Let's follow. Thank you.